Okay, so we have a joint PMF problem, and we're given this table. We have 4 sub-questions, and I'll show you how to do this. How do you find the marginal PMF of x and the marginal PMF of y? Well, the marginal PMF of each of x and y are just the opposite dimension. So x is the columns, y is the rows, added up. So let's take a look. You use this notation. You can write a new column and a new row, and you simply add up and put it here. And these should both add up to 1. So this is the formula that is pretty self-explanatory. And we just do for each x, we do like this. So the 2 rows and add it up, place it here. For this, 2 columns, place here. We don't really need this work, I'm just showing it, but we could do it all here. Now, second part, are x and y independent random variables? You know if variables are independent if they satisfy this formula. F of x and y equals fx, x, and fy, y. Well, what is this? When I first saw this on the quiz, I didn't know how to work with this. I thought it was like, what are we inputting into? But this is the joint PMF. This is the whole point of having a joint PMF. So it's simply, this is our x and this is our y input. So just test your pairs. This one we retrieve from using our coordinates and looking it up on the table. The other one, we use our marginal PMFs and multiply them. So on the left side, let's do it. For 0, 0, we have x equals 0 and y equals 0. So in our table, that's 0.15. So we're gonna put this here. Does this equal the other side? F of x 0 and f of y 0? Well, let's check. We got 0.5 and 0.3, and that equals 0.15. So this works, but you need to check multiple. Just because one works, we need for all x, y this to work. So this is actually not independent. I didn't check 1, 0. Now, how do we calculate p of x is greater than y? Well, just write out all combinations of the x and y labels. We want to do it in a similar way that we do truth tables, with like 0, 0, 0, 1, 1, 1. For one of them, usually the y, because it usually has less. And then we write our x, 0, 1, 2, 0, 1, 2. And that should get all combinations. And then we check, hey, is this greater? 1 is greater than 0? Yeah. 2 is greater than 0? Yeah. 0 is greater than 1? No. Then we just turn these into coordinate pairs. 1, 0, 2, 0, 2, 1. And then we look them up in the table. So 1, 0 is 0.1. 2, 0 is 0.05. 2, 1 is 0.15. X going before y as usual. And then we get 0.3 as our sum. So this is our p x greater than y. And then last part, determine the PMF t of x plus y. What you do here is you want to create essentially a new table, tx plus y, and for the labels, you write them as normal, and then for the values, you just add them up. It's pretty simple. So we get these. And what do we do with these numbers? Well, we input them into t, which is kind of a formality, but in reality, we're just trying to find all combinations that, as inputs, add up to these values. So for 0, we only have 0, 0. We can't have anything else. For 1, we can add 0 and 1, or 1 and 0. Both equals 1. So we have these two combinations. I want to add these for ft1. For this, 2. 1, 1 and 2, 0 work. So take these, add them. For f3, the only 2 and 1 work. And then we just create a new table as follows, and this also adds up to 1.